Two parallel plate capacitors X and Y have the same area of the plates and the same separation between them. X has air between the plates while Y contains a dielectric medium of dielectric constant 4. Calculate the capacitance of each capacitor if the equivalent capacitance of the combination is 4 microfarad. Calculate the potential difference between the plates of X and Y. Estimate the ratio of electrostatic energy stored in X and Y. So in this question, there are two capacitors X and Y, and they are connected in series, and you are provided a potential of 15 volt. Now, in the first part, they are asking us to calculate the capacitance of each capacitor. So we need to find out the value of Cx and we need to find the value of Cy. Okay. Now, the equivalent capacitance of the combination is 4 microfarad. So, since it is a series combination, we can write down the formula for series combination, that is Cx into Cy divided by Cx plus Cy, which is equal to 4 microfarad, which is given in this question. Okay. So, we can see that here so in the first part they have mentioned that X and Y are having the same area of plates and the same separation between them. X has air between the plates and Y contains dielectric medium. So if you write the capacitance of X, Cx, we can write it as epsilon 0 A by D because it contains air in between the capacitor plate. And we can write for Y, Cy is equal to, here you have a dielectric medium, so it will be K epsilon 0 A by D. The value of K over here is 4, so 4 into epsilon 0 A by D. So if you compare the Cy with respect to Cx, you will be getting it as 4 into Cx. So we got a relation connecting Cy and Cx. We can substitute in this combination formula. So in place of Cy, we can write it as Cx. So Cx into Cy, that we can write it as 4Cx divided by Cx plus 4Cx will come, which is equal to 4 microfarad. So if you simplify this, what we will get? We will be getting 4Cx squared divided by 5Cx, which is equal to 4 microfarad. We can cancel 4 on both the sides, and you will be getting the value of Cx as, you can cancel Cx also on the numerator and denominator, and you will be getting the value of Cx as, so you will be getting the value of Cx as 5 microfarad. So we got the value of Cx. Then Cy will be 4 times Cx. So 4 into 5 microfarad will be getting 20 microfarad. So this is the value of Cy. So this is the answer for the first part. Now for the second part, we need to find the potential difference between the plates of X and Y. So we need to find out Vx, and we need to find, this is for the second part, we need to find Vy also. What is the total potential difference across the series combination of capacitors? It is 15 volts. So that is Vx plus Vy will be equal to 15 volts. So since it is a series combination, what we can say about the potential difference? That will be different for each capacitor, but charge flowing across the capacitor will be the same. Since charge is same, what will be the total charge flowing through the combination? This is equal to C equivalent into the total potential difference. And in the first part of the question, they have mentioned the C equivalent value. How much is that? 4 microfarad. So we can write down 4 microfarad. So 4 into 10 to the power minus 6 into the voltage supplied. How much is the voltage supplied? 15 volt. So if you solve this, you will be getting 60 into 10 to the power minus 6 coulomb. This is the charge. This is the total charge flowing through the combination. So once we get the total charge flowing through the combination, we can calculate Vx. How much will be Vx? Vx will be equal to Q by Cx. That is Q, 60 into 10 to the power minus 6 divided by Cx. Cx is 5 microfarad. 5 into 10 to the power minus 6. So we will be getting it as 12. Once you get Vx, Vy you can get it from this equation only. How much will be Vy? Vy will be equal to 3 volt. This is the answer for the second one. Now for the third part of this question, you can write it over here. Third part, what they are asking? They are asking us to calculate the ratio of electrostatic stored energy stored in X and Y. So the formula for energy is, for the first capacitor Ux will be half Q square by C. So the charge will be same. That is why we can use this formula. So charge is how much? 60 into 10 to the power minus 6 whole square divided by 2 times Cx. How much is Cx? That is 5 microfarad. So 5 into 10 to the power minus 6. And what will be Uy? Uy will be equal to Q square by 2Cy. So we can write as 60 into 10 to the power minus 6 whole square divided by 2 into Cy is how much? Cy is 20 into 10 to the power minus 6. So we can just take the ratio of these two, that is Ux by Uy. What will you get? The charge and all those things will, since charge is same, Q square will get cancelled. Ux by Uy will be basically by Cy by Cx will come. That is nothing but 20 into 10 to the power minus 6 divided by 5 into 10 to the power minus 6 will come. This is nothing but 4 by 1. So the ratio is 4:1. So this is the answer for the third. Thank you.